All right. Thank you for joining us for the PH Mass monthly July meeting. I'm actually just going to stay over here today rather than even trying to get in front and everything. Maybe I'll edit a picture of myself in the video. But otherwise, thank you guys for being here for the July meeting. This is the engineer's perspective on the Pass Fail process. Those of you who have been following along the last several months, we've been doing this. We started with the developer's perspective, then we went to the architect's perspective. Now we're on the engineer's perspective. In 2 months, you'll be back here for the contractor's perspective, but we'll get to that. All right. got some applause for that already. Sorry, I'm also admitting people here at the same time. I do want to thank MassSave, as I always do, for helping to put on these presentations, as well as fund the Passive House and All Electric Homes training program, which does a lot of lunch and learns and other events. We have a lunch and learn coming up at the end of the month with them, which I'll show you some information about in a moment as well. But thanks to them for doing that. And as I'm sure everyone in this room knows, that they've been funding buildings, incentives for developers for Passive House projects and all electric homes now for a while. So I'm not going to spend too much time talking about these. This is the all electric homes incentive for 1 to 4 unit buildings. This is the Passive House incentive program for Passive House projects 5 units or more. Really great incentives. What I do want to highlight tonight is the training incentives that they have. So in addition to funding the no cost lunch and learns and workshops, they also fund certification reimbursement. So the certified Passive House designer, certified Passive House trade person, certified Passive House consultant, DS verifier, all of these certification courses, you can get a 50% reimbursement through MassSave for the costs. Whether in person, the online, the on-demand, whatever version of the course you're taking, as long as it's the certification course that provides you with certification at the end, you can get 50% reimbursement. So definitely take them up on that.
I'd like to add one thing.
Yeah, please do.
This. The 3-year plan is being finalized again, the next 3-year plan. And it changes some of these. It doesn't really change what we're seeing on the screen now in terms of the Passive House program, but it makes some changes to other parts of the program. And we have a letter, I think, Aaron, you have it, that we should get out to the members, where we're suggesting our feedback to the EAC is that they increase the transformation adders that they're proposing for Passive House. Right now, it's a steady state funding of Passive House. Passive House is now getting more money, but it could get more money if they include more transformation adders. So people ought to, we'll distribute that letter if we haven't and make sure people have it, and they should make comments to the EAC. The other comparison we draw in that letter is that the commercial and industrial sector gets incentives based on so much per ton of heat pumps, et cetera, and it's significantly more than residential. So the other suggestion we're making is that we have comparable increase there. And effectively, these suggestions are about the only way we're going to increase these incentives based upon the kind of inflation we're seeing in the marketplace. So it's worth paying attention to that and supporting those suggested increases, because it's going to come together fairly quickly now.
All right, and as Hank alluded to, we can get more information out through our newsletter to follow up on this. But these have been very critical incentives for the state for a long time. We want to see them continue and improve. So, upcoming events. Tomorrow, some of you are, I know, are registered for this already. From 8 to 12, we're going to have a multifamily certification building verification workshop on the PHI process right here in this very sorry, not this very room. It's been moved over to the gallery space, but in the same building. Ken Levinson is here in the room with us right now. He's going to be back in the morning to lead that session. It's a great one. We do have a little bit of space, especially since we now moved over to the gallery space. So if anyone was hesitating about whether or not you want to go and you didn't want to sit in a crowded Pearl room, don't worry. You're going to be in the gallery, so register. Then that lunch and learn I was mentioning, that the Mass Save Lunch and Learn is coming up on July 29th virtually. It's a geothermal heating and cooling. We have information on the presenters and all of that on our website. So look into that, phmass.org. And then we're going to take August off. So we won't be back here for our monthly presentation, but we'll be back in September for the contractor's perspective on the Passive House. And that's what I have right now. Look to our newsletter for other updates and other events. But I'm going to turn things over to today's panelists. I'm going to start with James Peterson. Take it away.
Very much, Aaron. So this is a super familiar crowd. The idea of this series was to draw new people. So
Wrong month.
I knew.
Wrong-
I mean,
you're new. Oh, yeah. Hey, what's your name?
hello.
Aaron, is there a way for you to show us who's welcome, Galen?
Hi.
Yeah,
Welcome,
we'll
Galen.
get to you in a minute. Aaron, is there a way for you to show us the names of who's on?
Oh, yeah, there we go.
Yeah. Well, you got the names there. We'll do a gallery here just for anybody who's showing their video, which is me and Galen.
Hey.
You're in front of the camera, James. Watch out.
Oh.
You're better. You're better. That's you on the screen in the top right. Here, let me scroll down a little bit for you there.
Yeah. Christina McPike, thanks for coming, Christina.
Yeah.
Jerry, our newest electrical engineer, licensed professional engineer.
Nice.
Can people see these names? Anybody else want to give anybody a shout out? Luke McNeely. Welcome, Luke. Luke.
Hello,
Glad
glad to be here.
Ted. Great. Right, welcome everyone. So, so Lois, myself and Galen met once, got our work done with one short meeting.
I was vetoed several times.
Right, yeah.
You won in the end. Hopefully.
So, my big claim to fame is that I completed the, passive house training and I was in Lois's class.
Yeah.
I don't think she remembers me though. And I don't know what year that was. So Lois Arena is Director of High Performance Building Solutions at Stephen Winter Associates. And she possesses 25 years of experience in building science field. She holds both US and international passive house consultant certifications and is currently consulting on some of the largest and most difficult passive house projects in the world. I totally believe that. And she's got to make them work. She has co-authored and presented training programs about energy efficient building practices to professionals in all sectors of the building industry and is regularly invited to present like tonight at conferences and private firms around the world to discuss the benefits and the roadblocks to passive house adoption. So please welcome Lois all the way from the United States to New York. Great. So Galen is in Virginia. Thank you for joining us, Galen. Galen Stengel is president of Stengel Engineering, MEP Engineering, Design, Building Science and Energy Consulting firm based in Central Virginia. Galen has more than 25 years of experience designing cutting edge energy efficient mechanical systems for green building projects and industrial facilities. As a leader in low energy building system design, Galen regularly presents and moderates at national and regional green building conferences. He is also involved in advancing the technical and regulatory aspects of green building design in the US. He is currently a member of the National Technical Committee of Passive House Institute US and a voting member of the ASHRAE Standard Project Committee 227P Passive Building Design Standard. Galen, would you hurry up and get that done?
Yeah.
Galen, say something so we can say test one.
Can you hear me okay?
So, I don't know how we met, Galen. It was probably at it was for a project, Rocky Mountain Institute. Was that, related to that?
Yeah, that's right. Eva White, I believe.
Yeah, all right.
Why?
And And now we commiserate every time we see each other at a conference, which is fun. So we've got two great panelists. I'm the weak link. Here are the rules. But before we get into that, I'm going to surprise both Lois and Galen. Lois, we read all about your professional life here. You need to tell us one hobby, okay, outside of work. And then same for you, Galen. So who wants to go first? Tell us a hobby.
So I have two boys, they're 18 and 20. And I'm currently really enjoying and hanging on as long as I can playing soccer with them. It's probably the last season. This season I'll be able to do it, but I just really enjoy it.
Wow, that's very cool.
Yeah, I'll go the opposite end and stretch. Mine's vodka soda.
I'm a Manhattan guy. Manhattan guy. Okay, so let's see, a little bit more about me. So principal of Peterson Engineering, started the firm when I was 28 because I didn't have any commitments and easy. My parents thought I was actually being lazy starting with this. My mother was a school teacher. My father was, worked for a defense contractor for half of his life, a manufacturer. So they didn't get the whole start your own business thing. They thought it was a shortcut. I'm not kidding. So we have 20 plus employees. We've been committed to really high quality work forever, and that's what led to us being having a terrific reputation, especially in Massachusetts, and we really appreciate that. And sustainability and other things having to do with trying to raise the bar. If I think about the advances in cars over the 30 years that I've been doing this and the advances in buildings, cars are doing way better in terms of comfort, fun, looks,
Safety.
buildings. Yeah, buildings, comparison with buildings, until continuous insulation came along, we were insulating buildings using pre-World War II technology. That's fiberglass bats between studs. So it's pretty sad state of affairs. So that's the bad news. So maybe we can get positive now. So here are the ground rules. My hobby. Okay, so my wife and I bought 8 acres in 1996, and you'd be amazed at what the price was. In the very southern tip of Maine, and it had all the invasive species that are now banned. And they all got together and basically wrecked this 8 acres. So my hobby for the last 28 years has been beating back invasive species. And I started it with a wheelbarrow, a spade. This was my wife's dowry. She was a landscape designer and installer. A wheelbarrow, a spade, and loppers. And now it's gone from that to now I have a 50 horsepower Kubota excavator.
Yeah.
And it is so fun. Air conditioning, radio. I think,
Air conditioning.
yeah. I think. And child.
They actually bought a launch after this summer. I'm loving it.
The government should have given everybody, every man, woman, and child an excavator as incentives or whatever when they were handing out money. So here are the rules. So Galen, Lois, and I got together, and we just, what are our top, say, 4 topics? And so we came to an easy agreement. There are heating and cooling loads, oversizing and right sizing, square foot per ton, etc. Simplification, ductwork design, etc. Simpler designs, perimeter heat and cooling, for example, not required, and comfort, serviceable, easy to maintain, resiliency, passive survivability. So we're gonna cover those 4 topics, and we're gonna cover that, and then we're gonna leave plenty of time for discussion. Obviously, that's not a exhaustive list, So I think we're gonna have a good conversation, and hopefully we'll get some questions from folks online too. So the first topic, and we're basically, obviously we have a slightly different audience, but I'm gonna assume we have some newcomers online. So the lens that we're looking through this is we have experience as mechanical engineers working in these buildings. And how do we help people that are entering this area? With the lessons we've learned and what you need to know. So our first topic, heating and cooling loads. And Lois gets the first shot at how heating and cooling loads are impacted by passive building techniques.
So I'm the only one that has slides because apparently I'm the most rigid engineer here and I need structure. So you're gonna constantly hear me say, our data shows, because we've been doing this for so long, we now have a lot of buildings that have data, big buildings. So they wouldn't let me show you all my data. I got 3 slides that I can play with. So if you need more slides, tell me on. So this is a comparison of the peak heating and cooling loads at Cornell Tech. This is a passive house, our first large scale passive house, 22 stories, a lot of small units. And you can see in the final column that's all highlighted, that is the ratio of the cooling load to the heating load. So the cooling load, and this is done by the engineer's calculation after we checked his assumptions, because we wouldn't let him put, assumption factors in there to raise it even more. 2.5 to 4 times higher. The cooling loads are 4.5 times higher sometimes to peak heating. If you actually look at the way heating loads work in a passive house building, those peak heating loads would be much lower. So you're talking 5 to 6 times higher cooling loads to heating loads in these buildings. And I'm going to get into this a little bit later, but that affects comfort, it affects efficiency, it affects control. And so when we actually look at these buildings, our engineering brains, that new manual J, put in a comfort factor and make sure we oversize by this much, has to go out the window because we're actually making the buildings worse. So when you look at the way the passive house software calculates those heating and cooling loads, you have to pay more attention to those because those are actually right. And we did a number of studies over the years from DOE and some, other research that we've done for NYSERDA and things like that, that prove these numbers. They're great. And Mitsubishi even did a presentation with me at a PHI conference that makes it seem like these are even worse out of disparity than what I'm showing. So large buildings, multifamily buildings, they don't have to be that big. Multifamily buildings are going to be cooling dominated even in Boston.
So Lois, what's the implication of there being a big delta between the peak heating and the peak cooling?
So what you're going to get is really bad efficiencies in the winter because we're going to be cycling and cycling and cycling, and it's going to hit these design loads, right, are like at the design point of the year. And so they're even smaller when you're not at the design point of the year. So you're in such an imbalance in these systems. This was a VRF system, right? So and those have the smallest units in the apartments, right? So that's what we're dealing with. We need smaller equipment and we need better controls.
So Lois, pardon me if you're repeating yourself, but where is this building and what type of building is this, or is it not even regional specific?
It's New York City.
New York City. Okay.
It's 22 stories, 300.
This is the Cornell building.
Yep, Cornell Tech, 352 apartments.
Great.
What's the average size of the units? Like dorms almost?
They're each apartments. It's grad student housing, so they're individual apartments. Half of the floor, I would say 75% of the floor are studios, 400 square feet, and then the other are 1, 2s, and 3s. And that's for almost the entire height of the building. So.
I'd like to point out something as well, and that is that, when we're sizing equipment based on the cooling load for building as opposed to based on the heating load, we can take advantage of a lot more load diversity, right? And what that means is in the heating season, the entire building is pretty much at the peak heating condition at the same time when it's the coldest hour of the coldest night. But in the cooling season, those cooling loads peak at different times based on the exposure, whether it's a southern exposure apartment or a northern exposure apartment or whether someone's cooking dinner or not. So when you look at the building as a whole, you know, those cooling loads per apartment are pretty low. But when you look at the building as a whole, the cooling load for the building is even lower because there's a lot of diversity that we can take advantage of for the cooling loads.
Okay, so I'm gonna have the last word on cool loads. Anybody remember that? Was it the McLaughlin hour? If I need to, I might go that route. So I think what's really hard for non-passive house mechanical engineers is how miniature both loads are.
Yeah.
So, you know, there's in like any profession, I'm sure, we're hampered by rules of thumb. In this case, at least sometimes rules of thumb make sense, but not very often. So 400 square feet per ton is kind of a rule of thumb that you grow up with. And that your mentor taught you. Oftentimes, our peak cooling loads are 1,100 to 1,300 square feet per ton. So the interesting thing, or one difficulty, and why there's lots of reasons why mechanical engineers are going to be resistant to change. In this case, if you put in a system that's producing that little cooling capacity, you're essentially working outside the standard of care. So imagine the implications of that. Your standard of care basically is what are most of your peers doing? They're not designing miniature systems.
We have data that shows that a lot of our passive house projects are working at 0.3 tons per 1,000 square feet.
Wow.
Okay, convert that.
So you convert it.
Okay, well, someone's converting that to square feet.
Can you say that again? I didn't hear the number.
3,000 square foot per ton.
Okay.
And that actually supports other data I have on shop from Epica, from single family homes.
Is the occupant dead in that case?
So that's,
It's
so that's a cooling, that's based on cooling or heating?
That's cool.
That's
When you
cooling.
talk square feet per ton, you're talking cooling.
No,
And that's actually consistent with, you know, if you look at, FIAS has a metric for maximum cooling load, which is 3 point, well, it varies based on building type. But it ends up being about 3.2 BTUs per square foot. And if you do the math and reverse that, that ends up being about 3,500 to 3,800 square feet per ton. So 3,800 square feet of building per ton of cooling. And
So just to clarify for both of you, is that figure the load? Or is that what you end up putting in for size equipment?
that's the load.
The load, okay.
And we're not able to get to that from an equipment size perspective, typically, for a bunch of reasons. One, because equipment isn't made that small, right? In a multifamily building, we just saw Lois's loads, you know, down around 3,000 BTUs, and I think now you can get a 4,000 BTU head, but in the past it was 6,000 BTUs was the smallest piece of equipment you could get. And the other issue is that that's typically a building-wide number. So you might have peaks in different smaller spaces that are larger than that, you know, when the sun's shining in through a south-facing apartment. So the equipment that serves the apartment might need to be bigger, but if you have a central plant that's serving your entire building, you can get it closer to those kind of theoretical maximum numbers.
So Galen, you're segueing a bit, but I want to make it official. So now we're going to get into oversizing and right sizing. And you're already talking about that, but make a few more points about that.
Sure, yeah. You know, this is a critical issue for passive house buildings because, you know, we based this system around a concept that we're gonna downsize the mechanical system and move cost from the mechanical equipment to the building envelope. So we really need to be able to realize that and take advantage of these incredibly small loads that we see in passive house to hopefully realize some actual cost reduction in the mechanical systems. And James, you kind of alluded to this, but you know, that square foot per ton metric is a good way to think about, you know, is my mechanical engineer right sizing my mechanical equipment? And we've seen studio apartment buildings in the range of like 350 square feet per ton. So if you compare that to the 3,500 square feet per ton, which is your sort of theoretical maximum, we're off by a factor of 10. There's a lot of factors that go into that. Equipment size is one, and also equipment type, because if you use, say, 1-to-1 heat pumps for apartments, then you're not able to take advantage of that load diversity across the building. So you might end up with larger numbers. But we see a lot of our projects end up in the sort of 1,300 to 1,800 square feet per ton range. So it's a good number to keep in your head just to sort of see if the mechanical engineer is doing his job there. You know, also there's this issue of equipment size, and we see in studio apartments cooling loads as low as like 1,500 BTUs per hour, or even lower than that. So our minimum, you know, mini split head or VRF head that you can get right now is 4,000 BTUs per hour. So that's still oversized by a factor of almost 3. So we do, you know, we need smaller equipment to be able to right size and meet these loads.
Is the smaller equipment available in Japan or Europe or wherever?
Not that I know of.
No, really.
James, can I break your rules and
Yeah, oh yeah, I forgot to make the rule about questions.
Oh.
Okay.
Oh, what's
Yeah,
the rule?
you can ask.
You're allowed to ask.
We have a lot of flexibility, so if the crowd wants to ask questions as we go, the crowd can. If the crowd chooses not to, that's fine, but it could become a complex time management problem.
JS needs.
So I'm willing to take that on. JS, go ahead. What's your question?
from one of the manufacturers from Japan here now. So Galen mentioned a great point. One of the issues, especially in Massachusetts, with the decentralized nature of our multi-res, because of our tenant billing, is once a 200 suite building wants 200 splits, they only go so small. There's a technical limitation as to how small the compressors can go for each suite, especially if you want to run the refrigerant 60 feet, 80 feet, 100 feet for a 4, 6, 8 story. And that's the issue. So the importance of moving to VRV, VRF more centralized, you can at least take advantage in cooling of that diversity and right size. So the VRF heads, which is just a little valve and a coil, those are getting smaller. 4,000 is about where they are. The 1-to-1 splits, that's a compressor problem. So even overseas, about 3/4 tons is about as small as they get. You go any smaller, you'll be limited to just balcony mounts and things like that, which some places do in Japan, in Europe, some in Canada, here not as much. So it's more of a compressor limitation, especially to run the refrigerant along far enough from the condensing unit.
Yeah, I think that some of that is just sort of what the manufacturers perceive the marketplace needs. I mean, there are smaller compressors available in other industries. But the other, I just want to put in a plug, you know, we can go back to hydronics, and that allows us a lot of flexibility in equipment capacity. You know, it's still kind of not really in style and a little bit more costly, but this refrigerant change that's coming the end of the year here is sort of wreaking havoc on the VRF systems and split systems in multifamily buildings. So I think hydronics will start to look attractive again.
Good point, Lois. I'm gonna give you a chance to make a point on, equipment, oversizing, right size, and then we'll go to Hank. Sounds like you had a question.
I can't stop.
Can't stop. Are you gonna make a, announcement or do you have a question?
No, I have a question.
No,
Go ahead.
no, yeah, ladies.
Galen's point about hydronic is 100% right. We're moving a lot more of our New York, Connecticut, Massachusetts projects to hydronic. You're able to size better. You're able to control better. You put a little water source, heat pump, water air, heat pump in the unit. If I need cooling, I can have cooling. If my neighbor needs heating, I can have heating. That's the problem with some of these larger VRF systems that don't have energy recovery put in. It's either in heating mode or in cooling mode. And you'll see our cooling season is way longer now than our heating season. So comfort, which we're going to get into later, is very much affected by these sizing issues.
I just wanted to say one more thing before we move on. Hank, you made a comment about an incentive, which
Yes.
is on a per ton basis. And I would suggest if we have the ability to influence that, to maybe look at that on a per square foot basis, because we're reducing the tonnage in these buildings. So I don't think that it's right that we reduce the incentive that we're
Yes.
eligible for, because it's linked to the capacity of the equipment.
Boy,
That's a very good point.
Oh my God, yeah. So much meat here. Go ahead, Hank.
Well, I'm interested in this question of the central VRF system. And is it working with the existing equipment, or is it really gonna have to transfer to the hydronic systems to make it work efficiently?
There's so many questions around that, pros and cons. We have a chart, right?
Could you clarify his question? Because you seem to understand.
So if I think,
That'll help
Well,
me too.
should we abandon VRF and go to hydronic because it has more opportunity for savings and refrigerant, not less refrigerant loss and comfort control?
Is that it?
Is that
I
it?
think that's it, yeah.
Nice, Lois. Thank you. We're pushing a lot, especially with the refrigerant changes coming. We're pushing a lot more of our projects towards that. With the calculations on the global warming potential of refrigerant leaks, especially, we're pushing more of our projects to that. We're actually pushing a lot of our projects to the little individual ones in units.
So
Yeah,
we-
the other issue with VRF is that because the new refrigerants have flammable components, the code is very strict on how you move refrigerant around in the building. And all the manufacturers that we work with are very quiet about how VRF is going to work in this new environment. There's been discussion about having to put refrigerant sensors in every room. And we just feel like it's not going to be cost effective to use VRF with the new flammable refrigerants. So, there's some folks are suggesting moving to the hybrid VRF, which just brings the refrigerant to one place and then hydronics distribute throughout the rest of the building, which I think is a reasonable solution. And then the other would be, either one-to-one splits or going back to hydronics.
Yeah, so we're gonna keep moving here, but on that point, that Massachusetts code meeting this morning was a public meeting, correct? Okay,
Yes.
so then I can say this. So in Massachusetts, J.S. Rencourt, not only has he met several famous Montreal Canadiens, he has led the charge in addressing these requirements for the new refrigerants. And what's going to happen in Mass is they're going to reference an ASHRAE standard rather than international code council revision. That's not going to require, it's going to provide a pathway for not requiring ventilated shafts for transmission of refrigerant
For
dose. So,
certain height buildings.
okay, certain heights. Okay, so that's a big issue. It's hot off the press, and I don't want to go too far into the weeds on that, but that is, and when we get to Q&A, we can spend more time on that if people would like. So, Galen, just staying with you. Next topic, simplification. We got we had these micro loads, and so, how has the mechanical engineer's design approach been modified by that, or how should it be modified by that?
Yeah, so again, in the effort to reduce mechanical system cost and take advantage of the passive house envelope, I think it makes a lot of sense to focus on ductwork design. And if you look at sort of typical ductwork design for buildings in general or for apartment buildings, the approach has been to run ductwork out to the perimeter and flush windows with warm air to avoid comfort problems that result from double pane glass or leaky windows in the wintertime. And in fact, here in Virginia, the Low-Income Housing Authority actually requires you to do that because they just believe in it. But you don't have to do that in a passive house because it's designed so that the radiant temperature on the inside of the glass is within a comfortable tolerance. So in order to take advantage of that, let's design really small, short duct systems. Let's think about where we put our heat pump, put it in or our air handler in a central location so that we can basically just poke through the wall into the living room and the bedroom or wherever we're trying to serve and greatly eliminate the required ductwork in the space, which will help, reduce cost again.
Okay, so thanks for that, and thanks for the example. Lois, would you like to add to that?
So we only do perimeter heat where we have maybe very tall storefront.
You're a little soft spoken. Aaron, do you think everybody can hear her?
That's unusual for people to say to me.
Especially from New York.
No.
You're entering the lunch line at the deli, and you gotta move quick and speak loud and clear.
Speaking coach. So we only use the perimeter ductwork or perimeter heating, whatever you're gonna use, if we have really tall storefront or material or window systems that cannot meet the passive house standards. So, and you want to make sure you're preventing comfort issues, and it's only in stationary places. So say if you're walking into a lobby somewhere and we've got 2-story storefront, but there's no seating area, there's no library, there's no child play area, it's not necessary. But if you're gonna take it into a library or a daycare, and kids are gonna be on the floor, then you're gonna want perimeter heat if you don't have passive house levels of insulation and windows. But it's very rare in our projects.
Yeah, and so some of my simplification things that we've been working on is the assembly between the garage and the conditioned space above. And it's counterintuitive for a lot of people that if you put the air and the thermal barrier nice and low underneath your structure, that because your structure is highly conductive, you're basically, with this heat in the space above, you're basically heating that plenum space, and you don't need heat trace on pipes. You don't have a freeze issue. So that's really attractive to market rate builders. That was what got me particularly excited, because what they're concerned about is the bottom line. And for them, a huge headache is freezing pipes in garage ceilings and heat trace that doesn't work. So anytime there's something that can break, we want to try to eliminate it. I think what also, I'm gonna need to write a letter. I got a request for a letter today, and it was because we did what I thought was a pretty creative job in understanding whether a garage was ever going to go below freezing. And we determined that it wasn't. So now what we have is every garage is different philosophy, and they basically are. Some are completely like, they're like wind tunnels.
Yeah.
The building in Cambridge, your building, Michelle,
Yes.
it's a wind tunnel. And then you have the opposite with garages that are subterranean. And what we discovered is people are like one size fits all when it comes to garages. So there's a nice opportunity there. But I have to write a letter tomorrow to the plumbing code official that says, the space is not gonna get below freezing, and put my stamp on it. So I'm grateful at least that, he'll accept that.
Mhm.
And then when it does freeze, I'm in trouble. Okay, so we're gonna move along. So, comfort, serviceability, ease of maintenance, resiliency, passive survivability, and Lois is gonna take the first shot at this.
All of that in time.
All of that.
Can I have my
5
next slide?
5 minutes.
5 minutes.
I'm just kidding.
No, it's okay. I'll have 2 slides. You can go to the next one. Okay, we're gonna deal with resilience first, because this one's easy, because I have data. So the blue lines are all electric existing buildings. And the red lines are passive house projects. And what this is showing you is how the peak heating demand responds to outside temperature. And so the existing buildings basically linearly respond to the outdoor temperature, where the passive house ones just kind of float along the bottom. So we want to talk about resiliency during the heating system and power outages. There's your answer right there. You will not have to have your tenants move out. They act like super massive buildings that are not going to respond immediately to outdoor temperature. And this is why we also size differently for passive house, because you don't respond to that 1% temperature. You respond to an average daily temperature. Okay, so this is easy. Resiliency, done. We've proven it.
And Lois, I just wanna piggyback on that. This could be like your only reason for building passive house. It's so compelling. You know, if you have a Boston building and you have a cold, windy winter, day or night, and for some reason you lose heat, you have to start evacuating that building right away. You know, if it's 0 to 10 degrees and the wind's blowing, and that's not unusual. We've had this scenario where we had a sprinkler main burst, knocked out the building, and they had to, and this was a building that was housing people that would otherwise be homeless. So if that building were a passive house building, it would be a completely different scenario. It would not be an emergency.
Correct.
And that's the reason alone for passive house in my book.
And I've experienced this firsthand. I've walked into many apartments in the middle of winter where it's between 30 and 40 degrees. There's 3 people in the apartment, a couple of lights on. It's 72 to 74 degrees in the apartment and the heat is not on. It's set down to 68, right? They're heating the apartment with themselves. So I've experienced it firsthand, and then our data shows it too. So this I will stand by wholeheartedly. Yeah.
I think that this is the single most marketable aspect of passive house, especially on the market rate side. And the way I've summarized it for people is tell them they don't have to move to their mother-in-law's when the temperature goes down.
So see, I see this from the other side. I live in a passive house and my wife insists on sleeping at 67 degrees Fahrenheit. So she's able to keep the temperature at 67 degrees and the HVAC barely runs and everybody's happy.
That's a great example.
Lois, do you have that data on the other side and in extreme heat?
We're working on it now.
That's what I'm.
We got the heating fairly easy, the cooling with our next, so the next presentation I can get, we'll have it.
Awesome.
So Lois, are you prepared to address ease of maintenance, serviceability?
I want to talk about comfort. So
Oh, let's do that. Let's do that next
I think
then.
my next slide is comfort.
Let's check it out. Stand by.
Okay, we are no heat recovery, so it's either in heating mode or cooling mode. Deborah Mullis, who is the architect on this project, and myself stayed in the model unit, which was cantilevered out into the middle of space. This was in Cornell. And so we had a couple of floor units and one wall mounted unit. the heat is off in these buildings, in this room. It's 40 something degrees outside. Look at the temperatures coming off that VRF. So the deal is, if you have one person in a line of a VRF system that doesn't have energy recovery, everybody's gonna get the most minimal amount of refrigerant that goes through that line. Everybody on that line is gonna get it. So everybody on this floor, whether their thermostat was on or off, was getting this amount of refrigerant. And we kept wondering, why is the building so hot? And so Mitsubishi took this back and they did tests on it. And they said at minimum, they're getting 500 BTUs an hour from the
Wow.
system. And that's the peak design load. When I went to bed in this room on the left, it was 72 degrees in that room and I shut the door. It was 80 when I woke up in the morning and I did not have the heat on. So comfort, you have to design a passive house properly to really truly be comfortable. Okay, so yes, in the winter, dead of winter, you're golden. All the other parts of the swing seasons, you have to make sure you design for it. You have to give them the capability of cooling somehow in the swing seasons.
Can I ask about where shading would fall into this conversation? Because
Absolutely.
at Cornell, I don't recall had any, it seems to have been clad universally in the same way.
No,
all
that's
around the
true.
building.
So tall buildings, especially with high wind loads, are not gonna have exterior shading. They have the interior shading. It's too much maintenance.
Mhm.
These windows have a solar heat gain coefficient of 25. So it's low.
Yeah.
The internal gains to external gains in this building are 2 to 1. So all the heat is basically coming from inside the apartment. You've got one refrigerator per 400 square feet. You've got a few lights. You've got a couple of occupants. If you look at that load, that's more than the design load. And
On its own.
yeah,
Doesn't matter which.
doesn't matter what you do to the shading.
So you, that picture.
Well, hold on, Jace. Hold on. Galen, talk to us about comfort.
Mhm.
This was a.
So for me,
I was shocked and depressed.
I've always had a hard time talking about comfort as a mechanical engineer. But living in a passive house, it's just, and I have to say, I'll take a step back. When I was a kid, I lived in a farmhouse with wood heat. So I woke up every morning and it was 55 degrees in my bedroom. So I have a little bit of a different experience of comfort than some people do, but living in a passive house and watching the weather go by outside and not experiencing it temporarily is just an amazing and mind-blowing experience.
Yeah, I just wanna add my experience with that. So, I've designed, I don't know how many million of square feet for other people, but I finally got a chance to design some square footage for myself.
Nice.
It was a kitchen addition on our house in
Nice.
Portsmouth, and I designed it my way. And, the first night, it was a really nice kitchen. As a matter of fact, the wood was from our property in Elliott, by the way, because I also have a sawmill. Everyone should have a sawmill.
Also Kubota.
Oh, yeah. We already said that. We already
Yeah.
established that, yeah. So the first, and I triple glazed windows, and I just want to talk a little bit about radiation, because I think that's not understood well enough, and it's hard to get your head around. But the very first morning I came down, like you, I was looking at my watch and it said 7 degrees. I'm like, this can't be right. It was 7 degrees out, but you can't tell, with really high quality window and
Single family?
continuous insulation. Yeah,
Single family,
continuous insulation.
that was multifamily.
Yeah.
So different beasts.
Oh, yeah.
Yeah,
For sure. But the radiant point I just want to talk about quickly is the triple glaze, and this is something that Passive House has talked about from the beginning, is the interior surface temperature. And so single glaze, the interior surface temperature isn't that much different than the outdoor temperature. That's why you can have ice on that window. And double glaze, I remember looking at data on a cold winter day, your interior surface temperatures in the 40s. And with a really nice triple glazed window, your interior surface temperature is 67, 68. So your body is about 80, the surface of your body. So you are gonna have some radiant loss to a 68-degree surface, but it's not gonna be much. And so it makes such a difference instead of 80-degree surface with a radiant loss to a 45-degree surface. So then if you kind of take that to the next step, it means that a person's comfort can be met at a lower temperature because they're not experiencing radiant loss. And your comfort is dictated by a whole bunch of factors. The most common one we understand is sensible temperature. But now you can reduce the temperature, and that naturally brings up your relative humidity. Most places in the winter have a problem with low humidity. So even if it's not a passive house, but it's a pretty good building, if you're comfortable at a lower temperature, your relative humidity is going to be higher with the same exact amount of moisture in the air. So just a few points about comfort.
Yeah, that's another thing, you know, about passive house buildings, and I know Lois has talked about this before, but you know, living in my own passive house and having an ERV and a dehumidifier, because I'm in the South here and we do get a lot of hot and humid days like today. The humidity in this first winter that we stayed in it stayed above 35% the whole winter long. And in all other houses that I've lived in the area, it gets significantly below that. But just because of the tightness of the construction and also the ERV, the internal humidity in the space is maintained most of the winter.
Yeah, and isn't it terrific that you don't have to move to Florida?
Yes, indeed.
Because you're not going to dry out, and you don't have to be in a subtropical environment in order to be comfortable. So I don't know why anybody would move to Florida. So what we're going to do is we're going to open it up to Q&A, because I'm sure there's a lot on people's minds that we haven't covered or you want to discuss. I think JS, you had a response when we were talking about refrigerant. So why don't you kick us off?
Yeah, it was a question in the chat too, but your colorful picture about the VRF heating is, I want to add more color to it. But I'll explain why and a couple thoughts on it, because it's very correct. You said 500 BTUs, that's because there's a 10% bleed by of refrigerant, anything from heating. So we don't accumulate much refrigerant liquid and slug the compressor. That's why it happens. That's why you see that. 2 comments on it. Multi-res with no heat recovery, it's usually a big no-no. Of course, people try to VE it. Oh, you can save 20% by going and pump the heat recovery. That is one of the big problems. So you're bang on. We always recommend energy, heating and cooling, for multi-res. The second thing is, that's Mitsubishi, I think, I'm talking about Mitsubishi, whatever, but the industry of VRF has since somewhat solved that. So we can now limit, like, hey, we'll let you bleed by if you get too hot, we'll stop the bleed by for a while. So it's improved, in terms of trying to not always be at 92 or 97, I forget the number of degrees. It's improved, but especially in passive house, especially for floor mounted units, that are inductors, that's become an issue. Yes, heat recovery is always try to hold on to that as much as possible.
Yeah, we try, but our affordable projects are like.
Yeah. Yes, thanks for that update. So is there a question from our online participants?
Well, we have a few
comment?
here.
Hey.
I like the one at the end here. How should we deal with future weather effects on heating and cooling? You mentioned the impact, that it's already had on cooling loads, but
We hear that a lot. So who wants to? Oh, so why don't you go first?
So you saw how oversized our cooling is already anyway, so we're actually kind of not worried about it too much. I think it's more of an issue for the grid than for the equipment in our buildings. That's my perspective. I don't know, you guys probably have a different perspective, but in these types of large buildings, they have plenty of cooling to handle peak events and things like that. Can the grid handle it?
Galen.
So we do size our equipment based on projected. I think we've been looking at the optimistically at the 1.5 degrees C projections, for 30 years out, but I agree with Lois that, we're seldom in a situation where we have to worry about cooling loads just because of equipment sizing, unless we're dealing with really big apartments or other buildings.
I don't disagree with that. What I'm amazed, what I think is a bigger concern is water. The amount of tornado warnings in New Hampshire already this summer is like, it's pretty wild. So super high winds, wind driven rain, management of liquid water, flooding of your basements. Let's see, so someone that works in our office has been in her house for quite a while. Her basement flooded for the first time ever. One of our spring crazy rainstorms. So I think my concern is more so on that than heating and cooling. Is there another question from online?
We can go to the room.
Okay, go to the room. Yes, sir.
I'll try to put this together as the best I can.
I'll have Louis clean it up.
There seems to be a disconnect between architects and engineers. Architects like
Oh.
to design buildings with, as it pertains I'll say to permeability especially. and-
I'm joking.
Yeah, interior
Huge
moisture
disconnect.
management. Yeah, absolutely. So if you do your jobs properly, we hear a lot from architects about buildings, enclosure systems have to be built with very permeable layers because a building has to dry to the exterior. It's a very passive process, drying through the exterior, moisture load on sheathings and going through these permeable layers. But if it's properly designed on your end, you're going to have adequate levels of ventilation and dehumidification. So what's the point about having to dry to the exterior? Excess humidity.
Yeah, I love that. I love that question.
So
Go ahead, Lois. You go first.
excess humidity becomes a problem in a very few of our class house. I mean, it's usually where there's a very large number of occupants to space. And it's their generation of the humidity, the cooking, and then we saw only like maybe less than 1%, and it's less than that, it's way less than that. We had a few people call us, one apartment in a 180 unit building said, I have this apartment on the 4th floor. They shut their ventilation off. They're cooking and cleaning and showering. There's 4 women that live in this apartment and there's 3 mold on the walls, but not in any of the 180 apartments. So it's hard to manage it all the time, 100% of the time. But I think these buildings are built in a way that they'll dry to both sides usually. So if you have a moisture event from the inside or the outside, they'll be permeable. They won't be air permeable, but they'll be vapor permeable. So that's how we address it, especially in New York where you can't really use any foam products or anything like that. Really, it has to be mineral wool and things like that. That's all very vapor permeable. So
Yeah.
Can I respond to that as well?
Yes, go ahead, Galen.
I just want to say, don't rely on your mechanical engineer to dry out your wall sections. I mean, the building should stay dry if nobody's in it for, 5 years, regardless of the conditions. We design our equipment generally to deal with, active loads like ventilation coming into the space or like Lois said, if you have a bunch of people and there are a bunch of people showering, but please don't rely on the mechanical engineer to design a smart wall section.
do you guys recommend anything different for the first year after construction as far as moisture management? Because of vapor, moisture coming from the materials, the paint and the concrete and things like that.
Yeah.
In addition to that, you've got moisture coming from the materials and you often have lower occupancy because of rent up.
Right, it takes.
So you have, the first year of occupancy is not giving you the internal heat gain that you're hoping for.
And possibly the control.
So I'm aware of that issue. My sister built a new house and her windows were, double glazed and they were condensing in the first winter. And I just thought, not too long because I been thinking about this long time. I said, just open your windows. That'll be a dehumidifier. But specifically I have not been asked to managed, I committed the first year. But getting back to what's your name? Roland. So one thing I just love, I heard it years ago from, Betsy Pettit at Building Science Corporation, is have giant potential in both directions. And have your assembly be really simple. So the one assembly I got to design and build and live in has the air barrier, the thermal barrier, all continuous, all outboard of structure, no commingling of insulation within the structure. That's a 1930s thing. Didn't do that. And so I feel really, really confident about that. There's still risks though. I did have, the older section of the house, I put 6 inches of continuous on the roof. And I have a 1800 chimney popping up through the roof, and it was original. So we ended up having water leaking, the mortar had broken down. We had water going down the chimney and getting under the shingles, and it ended up rotting out the sheathing on top of the 6 inches of insulation. So that's an example of where if your crappy building may have been able to withstand that kind of situation. But when you have a good building, you're gonna have this, there's gonna be some liability that you run into. A circumstance like that was pretty disappointing to me. I think. But I had to replace the chimney anyways, and I should have done it when I did the major renovation.
Yeah, and you wouldn't have been saved by a more permeable room in that regard anyway, because you have a whole water intrusion and
You have asphalt shingles that are impermeable, you have, the insulation's impermeable, that water just got between those two layers and rotted that. Advantech is supposed to be incredible, not so much. Less than 5 years, it's mush. Yeah. Okay, how we doing on time? We're doing pretty well.
Are we?
Wait, how many questions or comments?
I have one more. One more.
I just want to say. You have immunity. You can ask as many questions as you want. Hank has been an amazing contributor to Passive House Mass, to advocacy for policies in the state of Massachusetts. He's done a wonderful job. Let's give him a hand.
Last question. You have not touched upon maintenance, right? And I think that we have to understand, what does it take to maintain these heat pump systems? And I'm gonna come directly from my own experience in my passive house, where I'm using mini splits and looking at the heads and looking at the mold that develops up in the vanes and bringing in the tech to clean that all out. And I think there's a hidden expense in the maintenance of these systems that we need to talk about and understand.
Yeah, so I think we all have something to say about that. So I'm gonna start with Lois. It's a big issue.
Is it something that wouldn't have happened in a normal cooling system? Is it different because it's a heat pump?
I don't know that. So you're suggesting, is it different than a room shaker, than a window unit?
I mean, they're both gonna have cold, they're both gonna have moisture. And the window one probably even more, is like, anytime I've ever taken out one, a dump of water's come out of it, you know? I don't know that it's different. I don't know, because we're not dealing with mold. What we deal with most on those are people concerned about how many filters will have to change in every apartment and how many times you have to change.
Well, what would the recommendation be for those filter changes? Because I think I think the manufacturers are going 6 months. And that gets to be, for a large multifamily building, a significant maintenance checkoff list.
And if they had room air conditioners in each window, wouldn't it be even worse?
It probably, I have no idea, but typically it wouldn't be the responsibility of the property manager. It's your window shaker.
Is it really? Is it really the owner, the occupants, the
Typically.
apartment occupants?
Yes.
Typically,
But you're just externalizing cost.
Yeah.
yeah.
And possibly making the whole situation worse, right? The whole situation worse. That's that's another one of those things that we always have in those pro cons table is like, who's the owner, who's responsible for the maintenance? Like,
And do you have a professional
yeah, what,
preventive maintenance contractor that comes by every 6 months? Before winter and before summer?
I don't, but I should,
Yes.
because I went back to him and said, I need you, and he said, I can't be there for 2 months.
Yeah,
Yeah.
so people aren't taking care of their buildings, doesn't matter what kind of building it is, so they spend all this money and then they cheap out on maintaining the building. But Galen, let's go to you as a general category, make some comments about maintenance or maintainability.
Sure, yeah. So this is obviously a lot of our work is low income housing, and maintenance costs are a significant issue for low income housing operators. We have we have the good fortune of having repeat clients that have done implemented different system types. We have generally found across the board that the simpler the system, the lower the maintenance costs. Specifically, the lowest maintenance costs that we see are 1-to-1 split heat pumps. VRF systems generally have a higher maintenance cost, just because I think it's a more highly trained tech that has to service them, and they have more complex controls associated with them. Hydronic systems as well tend to be more complex and require more specialized maintenance tech. So the more complex the system, the higher the maintenance cost is what we generally see.
Just want to double down on that. So whenever there's an opportunity to take pieces and parts and equipment off the job, that's what we want to search for. So what that's led us to, we used to have a lot of different system choices, but now in multifamily, there seems to be consensus that if we use a DOAS system on the roof, we can minimize the number of parts. Instead of having individual ERVs in apartments. We can also dehumidify the air at its source, but that's different than maintenance. So, and we also have a large piece of commercial equipment now that we can spend a little extra money on and get a really nice piece of equipment. In terms of heating and cooling, we've gravitated towards VRF, and I think where the owner hasn't caught up yet is understanding that with these micro loads, they should be less concerned about people leaving their windows open or keeping the temperature too high or too low, that sort of thing. It's less impactful than it used to be. So we want to move that equipment out of the apartment. And then we haven't talked about domestic hot water, but we also want to move that out of the apartment. Because what we're doing is reducing the total number of things that can break or need access to. Another thing, and this is a plea to architects. So in exchange for freeing up all that space in the apartment, in its rentable space, what I'd like is, I would like to never have equipment above a ceiling. His chance of being serviced, I think, goes way, way down. What you should have when you think of equipment, you should have equipment where somebody can stand and reach out and open the access door and maybe eat their sandwich with the other hand. I'm serious about nothing above the ceiling, nothing squeezed in. Years ago, we designed a visitor center for Shaker Village in New Hampshire, and the architect gave us an attic, and at least we had the insulation up and over. And I said, boy, this attic's it's not a good design, and we're gonna have a rat's nest of a mechanical system. And his response to me was, I know you'll make it work. And it's not the response we're looking for. So that's a little bit about maintenance from my perspective. Next question. Go ahead, Laura Homage, PCA.
So-
You're next.
Thank you, Jay.
where you're going is you want whole build, to the extent you can, you want whole building systems. And we can generally get our affordable folks to
Yeah.
buy that.
Yeah.
How do we make the case that maybe you're gonna gain square footage that you can lease? You just talked about that. Like, how do we make a case to market rate to go in that direction? And have confidence that the utility bill is gonna be so manageable that they're going to be okay. They don't need to charge that as, you
Yeah.
know, they don't need to make the renter
Yeah.
take that cost.
It's hard to convince, people of something, right?
Is there more data? You have data?
Yeah, where is the data? What I would say is the biggest leak is hot water usage. I don't like that about a central system. That somebody can stay in the shower for 3 hours. And there's not consequences. So I think that's something to really think about. Massachusetts, you can't meter, domestic hot water. You can meter the water, but not the heat, not the energy. So I think domestic hot water, I address the heating and cooling. But whether you can convince somebody that that's the case, that there's the implications aren't gonna be severe. And also with your energy recovery at over 80%, like mid-80s, I understand the benefit of that, but can you convince a market rate owner about that? The other thing I want to say about ventilation and market rate is most market rate in Massachusetts, the ventilation is not done to code. So the distance between doing the ventilation as it is now and doing the ventilation to code is very expensive. To make that leap. That's a very difficult change from market rate to adjust to. Sorry if that was disturbing.
Even versus the new stretch code, in your opinion?
Well,
So let me tell you quickly about a conversation I had not that long ago. I was on a phone call with an owner, an architect, a builder, and we were talking about ventilation. I say, you can't use a corridor to convey air. You can't use the corridor as if it's a duct. And it's been in the code for decades. And so the owner is like confused because all of his properties are, yeah, we do that. And he says to the mechanical contractor, this jackass engineer just said this crazy thing. What's your answer? He says, "Just we do it all the time." Then he goes to me, what do you mean? It's like, and then well, is it against code or not to the contractor? And the contractor says, we do it all the time. So the owner got his answer. Ventilation is, for whatever reason, for code enforcement officials, for whatever reason, they don't understand it. And that's why the code violations are basically across the board. Then Ken, go ahead. And Ken, we're starting to run low on time and but nobody gets to leave yet. Ken, go ahead.
Thank you. So I was curious about your opinions on using ground source heat pumps for these system heating and cooling. What are the opportunities? What's the kind of sweet spot in terms of size of building that you're seeing or taking advantage of it? And it's my understanding that there are actually, I think it's Lexington, maybe Massachusetts, that has a infrastructure that buildings can plug into for geothermal. And why would an owner turn that down if they have an opportunity to plug into it?
So Galen, do you want to take that question?
Sure, yeah. So geothermal is great. Low energy costs, low maintenance costs, but typically a high upfront cost. And the passive house community has sort of steered away from geothermal because we've been trying to reduce the cost of the mechanical system and rely on the envelope to do the heavy lifting as far as energy consumption goes. But the new tax credit structures have really turned the economics on their head. And we're still trying to understand exactly how it works in different states, but the IRA offers 30% tax credit on geothermal for commercial building types, which includes multifamily residential. Then you can ratchet that up another 20% with domestic content and prevailing wage labor. And I understand that you can additionally apply that to LIHTC tax credits and get the entire HVAC system covered by tax credits. We have a project in Kansas City right now that is doing that. So if you have the space to do geothermal, the economics have really been turned upside down, and that the legislation is such that those tax credits are supposed to be in effect until 2033 when they start to ramp down. So you know, I think we've been looking at it on a lot of projects.
Well, we got a comment, and I didn't catch the name, that in Lexington, they don't have that yet, but they're going to.
But they're doing Framingham.
Framingham.
I guessed the wrong town. I'm from Brooklyn.
Yeah, go ahead, Lois. Go ahead.
Because the loads are so low, we can reduce the field size quite significantly. I mean, we've shown that to the contractors now. But it's also a very reliable way to produce your domestic hot water as well. When you have that hydronic loop in the system, you can then use your heat pumps, your water heat pumps to do your domestic hot water. You don't have to worry about the outdoor air to water, which can't really peak at really cold temperatures. And so you have a much more reliable way to get your domestic hot water electrified. And if that's what you're trying to do, and that's what everybody's trying to do. So most of our buildings that are really going full electrification are using water loop in the building.
Lois, I have a question for you. Is there an authoritative document that speaks to ground source heat pump efficiency and air source heat pump efficiency? Not both at the same time, but maybe two documents that we can go to.
We have one study that we're doing for the DOE right now, but it's only a building to a building, and it's our Hanks building, 425 Grand Concourse, which is 26 stories, 277 units, and a market rate non-passive house project built at the same time, similar size. And this one is, they're both air source. This was double oversized to what the loads were. This one was properly sized because we have a good engineer on that one. And they're using, I think, 3 or 4 times the energy. And the COPs haven't gotten above 1.6, 1.8 in the coldest times.
Because it's short cycle.
Yeah. So it's really kind of interesting. We don't have that data for geo yet, because our first big geo projects are just coming online now. They're just finally getting their blower doors and.
So for an air source heat pump that's properly installed, you have data
Here's
for
the
that?
data. All I have is the total.
Are you aware of any data?
Yes,
Public.
there's been neat data, there's been stuff, but I don't know on projects of that scale, but there are yes, there's.
Because we're not able to answer owners' questions when they ask us, what's the efficiency of a ground source heat pump?
Compared to an air source heat pump, yeah.
Period. What's the efficiency of a ground source heat pump system? What's the efficiency of an air source heat pump system? We don't have a impartial research paper that we can say, yeah, it's this and.
Follow up with me, because we have people in the firm that are heat pump specialists and are in all of this research. And I'm sure they'll tell me what other resources are to find. But the calculations suggest, and data on the circulation pumps suggests that the ground source loops have a very negative impact. That pumping energy can have a very negative impact on overall system efficiency. Just because you're using all that electric energy, the heat pump itself might be very efficient, but you're also now using all of this extra pumping energy, which uses a lot of energy, especially if they're oversized. So that's.
Yeah, so if you send me something, I'll send it to Aaron.
Okay.
And he'll send it to everyone that's here,
Yeah.
even the people online.
Even those people.
Yeah, I think that's a great point, Lois, and it's just like any other system. It can be designed well or it can be designed poorly, and I think that a lot of times engineers feel like, oh, we're putting in a geothermal system, so that's going to be energy efficient, and I don't have to sweat the details about system design and pumping design and all that. But there's a great reference by Kavanaugh and Rafferty that provides sort of rules of thumb for a good pumping system in geothermal. So if you follow those rules, it ends up being, you can get the pumping energy down very low.
And Galen, what were you just referring to? Is it a document or a?
Yeah, there's a geothermal reference by Kavanaugh and Rafferty, who are two of the geothermal pioneers in the 80s, 90s.
Is that something you can send to us?
Sure, absolutely.
Okay, I'm hearing, yes. Okay, so Aaron, any folks online that?
No questions. Some good comments, though, just clarifications about the Lexington and Framingham. And Mark, thank you for the updates on Lexington. It's great to hear they have 800 units of passive house multifamily projects over 6 projects that they're reviewing right now. That's incredible.
Nice.
Adopted the specialized code and the new zoning requirements for the T. And HEAT is the organization managing that Framingham geothermal project. So if anyone's curious, HEET.
Would they have some data?
It's a good question. Chris, maybe who's online, I don't know if you're just passing on the info, if you're connected to HEAT, but maybe they have some data from that.
Okay.
Good resource to reach out to. That's all we got.
Okay. So we can let people out of class early, or we can,
Yeah, one more.
yeah, okay.
With-
We'll stay. We're contractually obligated to stay until 7:30.
With,
Always has to
electrification
catch
of
a
hot,
train though.
the electrification of hot water, everyone going down that path, and
Yeah.
seeing solar hot water coming back into play again.
Were you at my presentation at Bessie?
No,
Yeah.
Yes.
the answer's no.
No, I am advocating for solar thermal tempering combined with drain water heat recovery. We have specified probably a dozen, air source heat pump, central domestic hot water heating systems, probably in a few 1-year jobs. But I don't get a really warm and fuzzy feeling. So what it's gonna be fine, but it is an electric driven compressor system.
Right.
And so now when you think about drain water heat recovery, which is recovering you take your shower, think about it this way. When you take a shower, it's a one pass. You're getting one shower and you're dumping this water down the drain. You put a lot of effort into heating and it's going on. It's one pass. It's like littering. That's what it feels like. Drain water recovers about half of that energy. It's pretty impressive. And it has a COP of infinity. There's no pumps. And then solar thermal, people talk about COPs of 3 or 4 or 5, not 5, but 3 or 4. Solar thermal pre-tempering, what we looked at is not trying to cover like 85% of the load, but just trying to cover 50% of the load and trying to cover like all of the load in July and August. And so we got a 100-unit multifamily down to a reasonable size array, and it was covering all of the domestic hot water heating in the peak of the summer, and then some of it in the shoulder seasons. And don't even try to do solar thermal for December, January, February, just forget. But we calculated the COP on that because we're running a pump of like 231. So those two, the combination of those two, now what that says to me is the likely COP of air source heat pump central system is like 2 or 2.5. There's some electric resistance using those systems. So say it's 2 or 2.5. So now say the combination of drain water heat recovery coupled with solar thermal, say that cuts the amount of energy you have to add to hot water to make it good for a shower in half. Now that's equivalent to COP of 2 if you just use good old fashioned electric resistance water heater tanks. I kind of
Are
like
you,
that
are
solution.
you reducing the size of the tanks because you're able to?
With the drain water, because that's happening every time someone takes a shower, whether it's summer, winter, fall, or spring. You're downsizing the central
You're
system.
downsizing the system.
With the
That's
solar, because of December, January, February, where you get nothing,
right.
you're covering some of the load, but you don't get to downsize any.
Right.
Great question. So I'm pretty excited about exploring that option.
We don't, our buildings are too tall. We don't have enough roof area to even cover a small percentage of it, and it's more moving parts, more maintenance than PV. So where we can, we put PV on the building. A lot less expensive. You get a good amount to offset the electricity. So you're not gonna directly offset it in the tank. But that's how we do the solar.
And that's a good point. When we add solar thermal, what we're doing is breaking our rule. We're adding a mechanical system. But it just seems like we should consider it. Okay,
Depends on how
Galen.
much roof area.
That-
Depends on how much. roof area.
So, yeah, I guess to echo what Lois was saying, we end up in a situation where we're competing with roof space, competing for roof space between a solar electric and, in some places we have a green roof requirement, and then outdoor equipment if it goes on the roof. So the only place that we're doing solar thermal right now is in DC, which has very attractive RECs available for solar thermal hot water systems. Or if the owner is really comfortable with it, because a lot of owners feel that it's very high maintenance, but some of them are more comfortable with the maintenance requirements.
Okay, so Lois cannot miss her train.
I'm,
You had 20 minutes to get to the
to
train
get to the
station.
train station.
Okay,
Yeah,
that's about right, locals.
that's 5 minutes, right?
All right. So, Galen, thank you very much for popping in from Virginia.
Yeah, thank you very much for inviting me, everybody. I'm sorry I couldn't be there in person this time.
On the train that made every stop on the way. So, thank you, Lois.
Thanks, Jane, for organizing.
Thanks to everybody online and thanks for everybody for coming out on a school night. Thank you.